So this is the Scratch arena once again. As a little reminder, over here on the top left we have the stage area. Beneath that is where all the sprites are. To the left of that also is where we can change the backdrops. In the middle we have the scripts, costumes and sounds, and then on the right hand side is our sort of workspace where we will actually put all these blocks together and sort of create our project. So we're going to have a look at the events section first of all. Now you'll notice there's a green flag and a red stop sign. The red stop sign, not for nothing, is the same shape as the stop sign on roads. And the green flag obviously means to go, and what that will basically do is it will start your program. Even if when green flag is clicked, blah 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 blah, even if that's not the starting point for your program, even if that's not there and you've got this instead, you need to press that green flag to actually get the program started, and then whatever you've programmed after that point will hopefully kick in. So we're going to go with the green flag, we're going to go into motion, and we're going to go for 10 steps, moving 10 steps. Nice simple program, animation, so it's a good starting point for any age group, any ability level. Now what's going to happen here? Well, you tell me, take a moment, have a think. Hopefully it's reasonably self-explanatory. I'll give you a moment. What's going to happen is when we click the green flag up here, it's going to move to the next block because they're connected together. If it was here, nothing would happen. Press the green flag, nothing happens. They need to be connected. And you'll notice when you drag blocks over, you get a sort of thick white line. That's how you know that when you let go of the mouse, it's going to attach itself. Working with quite young children doing this, that's quite a good stopping point to get them actually thinking, you know, well, what am I expecting to happen here? What's my prediction for this? These are all critical thinking skills that they need to develop. So he's going to move 10 steps, we expect. You click on the flag, he moves 10 steps. Click it again, keep running the program. Basically what's happening is after this 10 steps thing, the program stops, it's finished, it's done everything it has to do, end of. This number 10 in the number of steps that he moves, this is a variable. We talked about these briefly in video 1. The fact there's a variable literally just means that it can change. A variable in a kind of a normal program would be something that the user who's using the program can impact on. The code itself is set, but the user of that program can type in things or can move things around or whatever it might be and have an impact on what the program does. And the things that the user can change, things that can be changed in the program once the program is finished and is being run by somebody, those things are variables. And in Scratch it's no different. So the number of steps he moves is a variable, meaning it can be changed, which means we can change it to 100, and then when we rerun the program he moves a much greater distance because clearly he's moving more steps. So when Scratch moves, anything happens on the screen really, and you change that number from 1 to 10 to 100, whatever it might be, those steps that it's moving are actually pixels on your screen. Pixel is a weird made-up word that means picture element. So if you imagine that every pixel is an element of a picture, and effectively what it means is if you zoom in on any picture, you will see eventually that it is made up of these little tiny squares. Each of these squares, zoomed in here of course, each of these squares is a pixel, and it's these pixels that Scratch is moving across when he moves across the screen. Conversely, this image isn't zoomed in at all. This is at 100% scale. This is an example of pixel art. Things like Minecraft have made blocky graphics suddenly cool again. These days, more modern graphics mean that pixels aren't really as obvious, particularly when you're playing things like games. This, however, on the Commodore 64, you can literally see all of the pixels that make up the graphics. A more innocent age. If we look instead as a comparison at Scratch 3.0, again we go into events and we choose when clicked, and we go into motion and we move 10 steps, just like we did in Scratch 2. All of these things are the same. As it's a variable, so we can change it to 100 steps. I think 1,000 might be too much, just get you back where we can see you. And then when we run the program, Scratch moves 100 steps or 100 pixels each time the program runs. And there you go, that's your first program. A legitimate, complete, fully functional program.